Now let's see the second section of chapter 3, that is the coordinate system in 2 dimensions. What does the coordinate system mean? What do we mean by coordinate system? So we have to know the meaning of a coordinate system. A system which has can be represented by this x-axis and y-axis. This is the x-axis and this is y-axis. This is called a coordinate system. So in this lesson we are going to see you may be given a vector which has 2 dimensions. Like for example, if this is a vector physical quantity which is represented by, if this is a vector physical quantity which is represented by this arrow. So this is in a 2-dimensional motion because this vector has 2 dimensions. Part of this vector is along the x-axis. If this is vector v, so this coordinate or this part of the vector is called vx, or the x component of the vector, and this vector is called the y component of the vector. And this is called an angle, and this angle is called theta, or you can call it theta or alpha. Theta is the angle between the vector and positive x-axis. This is the angle. So a vector can be represented in 2 dimensions in this way. That is, v is defined as the vector v can be written as, this vector is written as the vector part of the vector along the x-axis plus vector along the y-axis. This is how we represent the vector, because this vector has 2 components. One is x component and the other is y component. That's why we call it 2-dimensional motion. It is not like this vector is neither in the x-axis nor in the y-axis. It's in the middle. In the middle means it will have 2 components. One is the x component of the vector and the other one is the y component of vector. So next step is we will look for a way how to find the x component and the y component. This is called the y component of the vector and this is the x component of the vector. So this is called, we will resolve. The given vector can be resolved. That is called resolution of vectors. When we say resolution of vectors, we split the given vector into its components. That is, if a vector is given, we will just split the vector into its x component and into its y component. And this is called resolution of vectors. We'll see examples next to this. Now let's see, for example, this airplane, like the motion of this airplane can be represented by 2 ways. We can represent in 2 ways. A plane traveling northeast with a velocity of 300 meters per second can be represented in either this way or this way. This is, we can represent, this is the plane is traveling or moving at a velocity of 300 meters per second in the direction of, this is by the way, this is called northeast. You can use the Cartesian coordinates like this is the north, south, west, east, and this is northeast, this is southwest, this is southeast, and this is northwest. So we can represent the motion of this plane in 2 ways. One is the plane is moving in the direction of northeast at a speed of 300 meters per second. So like we can choose, like, you know, this we can say this moving in the direction of northeast. So moving along the y-axis in the direction of northeast. Or we can also represent by this plane is moving at a velocity of, this is a velocity vector which is 300 meters per second at an angle of 45 degrees from the positive x-axis. We can also represent by this angle is 45 degrees. So we can represent the motion of this vector by the plane is moving at a velocity of 300 meters per second in the direction of at an angle of 45 degrees from the positive x-axis. That's how we represent. So the motion of a plane can be, or any object can be represented in either of these ways. Now let's see how to determine the resultant and magnitude of a given vector. The resultant or the magnitude of a given vector and its direction. So to find the resultant vector, it's very important to know the Pythagoras theorem. We have to know Pythagoras theorem. If this is a right angle triangle, the right angle triangle is a triangle with 3 sides and one of its degree measure is 90 degrees. A right angle triangle is a triangle with 3 sides and one of its degree measure is 90 degrees. That's why we call it right angle triangle. And the side opposite to the 90 degree is called hypotenuse. This is called hypotenuse. And hypotenuse is the longest side. So this hypotenuse can be calculated, or this resultant vector can be calculated by Pythagoras theorem. Pythagoras theorem says that the sum of the squares of the two shorter sides is equal to the square of the longer side. This is called Pythagoras theorem. The sum of the square of the two shorter sides, that's a square plus this a square plus b square is equal to c square, the hypotenuse square. Or, like for example, if you have vectors, two vectors, this is one vector, that's the displacement along the x-axis, and this other vector, that's the displacement along the y-axis. So the resultant vector d square is calculated by the sum of the squares of these two vectors. That is the displacement along x square plus the displacement along y square. So this is called Pythagoras theorem. A Pythagoras theorem helps us to find the resultant vector of two vectors and the direction. And if the direction is calculated, this is the angle that the resultant vector makes with the positive x-axis. So a Pythagoras theorem can be applied or can be used to find the magnitude of resultant vector and its direction. So let's see this right angle triangle. Now here there are rules of trigonometry. These are very important. For this part, this is called a right angle triangle because this degree, one of its measure is 90 degrees. This is 90 degrees. So if one of the measure of the three angles is 90 degrees, the triangle is called right angle triangle. This triangle is called right. Right means 90. This kind of triangle is called right angle triangle. So right angle triangle is a triangle in which one of its degree measure is 90 degrees. So as I told you before, the side opposite to the 90 degree is called hypotenuse, or hypotenuse is the longest side. Hypotenuse is the longest side. And the side nearest to a given angle is called adjacent side. Adjacent means the nearest side. And this is opposite side. The side opposite to the given angle is called opposite. Now I want to show you the trigonometric ratios. I want to define what's the meaning of sine, cosine, and tangent. By definition, sine of an angle is defined as the ratio of opposite side divided by the hypotenuse. And cosine is defined as or cos. You can write this as shortly as sin. Sin means cosine, and cosine is cos. So the cosine of an angle is defined as the ratio of adjacent side divided by the hypotenuse. And we know that hypotenuse is the longest side. Hypotenuse is the side opposite to the 90 degree, or it is the length of all the sides, the three sides. The third one is tangent of a given function, or tan. We call it tan. The tan or tangent. Tan or tangent of a given angle is defined as, you can write it as the ratio of sine or to cosine. This can be defined as the ratio of opposite side over, this is opposite side divided by the hypotenuse. That's how it is. So these are the three common trigonometric functions or ratios. The sine of an angle is defined as the ratio of opposite side to hypotenuse. For example, the sine of this angle is the ratio of this side divided by the hypotenuse. The cosine of this angle is, this is the adjacent side for this angle divided by the hypotenuse. Tangent of this angle is defined as the ratio of its opposite side to adjacent side. So these are the three most important trigonometric functions or ratios that we are going to use in our next lessons. We are going to use these definitions. These are definitions of sine, cosine, and tangent. So let's see example now. Let's solve example. An archaeologist climbs the Great Pyramid in Giza or Egypt. He wants to climb. The pyramid height is, there is a pyramid, and the height of this pyramid is, this pyramid looks like, it's an Egyptian pyramid, and the height is, it looks like this, and the height is 136 meters. The height of this pyramid is 136 meters. And the width of this pyramid is, the width, when it's a width, this is a width. This is a width. This is 2.3 multiplied by 10 square meter. And don't forget that the width is, when you say 2.3, this is very important, times 10 to the power of 2, I can write it as 2.30 times 100. 10 to the power of 2 means 10 times 10, which is equal to 100. So this is the same as 230 meters. So the width is, the distance from one end to another end is 2.30 times 10 to the power of 2 meters, or this is equivalent to, this is the same as 230 meters. That's the width. What is the magnitude and direction of the displacement of the archaeologist after she climbs from the bottom of the pyramid to the top? She climbs from the bottom to the top. So what is the displacement? We are asking to, like, the displacement of this. This is what's asked. That's D. We are asked to find the displacement of this archaeologist. This archaeologist is climbing up the building, so we want to find the displacement of this. So just like this is very, what you have to know is we have to find this, first of all, this length, because this all is a width. If this is 230 meters, and what will be its half? Half of 230 will be 115 meters. So this is one, and this is, don't forget that this is angle, and this is angle theta. And the length from this to this is 115 meters. This is half of this 230, which is 115 meters. So we want to find the displacement and angle. We are asked to find the displacement of this archaeologist and the angle that is between the resultant vector and the positive x-axis. So this is like, you can do this as this is the same as, like, we have a reference point, that is say this is our x-axis, this is our y-axis. So this is change displacement in along the x-axis, and this is the total distance displacement along the y-axis. So to find the displacement of this archaeologist, we use the Pythagoras theorem. That is d squared. I will use the rule d square is equal to, d square is given by using from a right angle triangle from the Pythagoras theorem. If you have a right angle triangle of this type, if this is A, if this is B, and this is C, we know that C square is the same as A square plus D square. This is Pythagoras theorem. So I will read that. D square is the displacement along x square plus the square of the displacement along the y. That is d square is equal to displacement along x is 115 meters square plus the displacement along the vertical axis is 136 meters square. So use calculator and find, you'll find that 115 times 115 will be, when you multiply 115 two times, what will you get? You can use calculator. Then that is, use calculator, 115 times 115 will be, you can use calculator, 115 multiplied by 115, that is 13,225 meter square plus 136 times 136 will be 18,496 meter square. So this is the same as when you add these two plus 13,225, you will get 31,721 meter square. That's d square. This is d square. So to find d, you take the square root of both sides. So d will be, take the square root of this, the square root of 31,721. You will get 178 meter. The displacement of the Hercules is 178 meter. This is the displacement of this Archaeologist. Now we want to find the angle that this resultant displacement makes with the positive x-axis. What's the angle between them? So to find the angle, we use the tangent of the given angle. We will use this tan of, because I know the vertical displacement and I know the horizontal displacement, I can use tangent of the angle is tan theta is defined as the ratio of opposite side to hypotenuse. We will take the ratio of the opposite side to hypotenuse. That the opposite side is 136 meter divided by the hypotenuse, and the hypotenuse is given by, I mean, the ratio of opposite side to the adjacent side. That's 115 meter, because we know that tangent is defined as opposite side divided by the adjacent, and the opposite side is 136 meter, and this adjacent is, this is opposite side, this is opposite side, and this is adjacent side. This is adjacent side. So the side opposite to this angle is 136 meter, and the side adjacent to this angle is 150 meter. So when you take the ratio of these two, you will get, you can use calculator, tan theta will be, take the ratio of 136 divided by 136 divided by 115, and you'll get, so tan theta is 1.1826. Now this is a value of tangent, so we want to find the angle theta. So to find theta, theta is defined as the tangent inverse of tan, that's tan inverse of 1.1826. So to find the value of the angle, what you do is go to your calculator, click shift and enter this number. What you do is you click shift and put the numbers. Click shift and write tan, followed by writing the numbers 1.1826. That will be, this is 49.8 degree. The value of this angle is 49.8 degree above the positive x-axis. That's how we find the displacement of the archaeologists, and angle that this displacement makes with the positive x-axis. So the resultant displacement is 178 meter at an angle of 49.8 degree above the positive x-axis. That's how we define. Because displacement is a vector quantity, we need to describe it by a number and a direction. So the direction is calculated by calculating the angle that this displacement makes with the positive x-axis. That's how we find the displacement of an object and its angle.